Greetings, Saintsmen. This is our lesson on algebraic reasoning, lesson 2.4. Now, what we've discussed in this course so far is that we're going to work via proof for what we're going to do mathematically in geometry. And in order for us to do that, we're going to only utilize one form of proof. Again, you're not going to utilize this pretty much anywhere outside of this classroom, which I think is frustrating from some students. But I want to take us through the exercise of doing a two-column proof. And again, you're not going to use two-column proofs outside of this geometry class. But what it's going to help us do is going to have a very logical and well-formulated argument when we do something. So when we are going to make some sort of take some sort of a mathematical step, we're going to call it a statement, and then that's how we're going to show our work, and then we're going to explain our work through reasoning. And of course, the reasons that you guys can use are going to be postulates, definitions, and theorems, and then properties. Okay. And you already have a number of mathematical properties at your disposal. So let's first discuss the addition property, which shows that it's when we should have x minus 3 equal to 5. It's the step where underneath we are adding 3. It's that inverse operation we're going to do to both sides. Okay, again, what that also will look like sometimes is going to be this, you're going to see x minus 3, but then there's that plus 3 is equal to 5 plus 3, okay? So here, it's any time that we are adding 3 to both sides, plus 3, right? So that's our addition property, okay? Subtraction. Let's go ahead and adjust this real quick. So tables are going to do that on us. We're in x plus 3 equaling 5. And of course, to both sides, we're going to subtract 3. Okay. And again, the other way we'd see what this looks like, right, is through, so x plus 3 minus 3, and then we'd have 5 minus 3, because some people prefer to see this horizontally versus vertically. I think you've been taught vertically to take those inverse operations, but it's effectively the same thing as long as we're doing the same to both sides. That's subtraction. Okay. Next is the notion of the multiplication property. I'm just going to abbreviate here. Why not? Okay. And showing us again that we have x over 3 equaling 5, okay? And then that multiplication is where we're going to take times 3 on both sides, times 3, right? That's going to be our multiplication property. Moreover, we have the division property, which is going to be 3x is equal to 5, okay? And that division, again, divide by 3, okay? So there's the division on both sides. Okay, so those are some of the basic properties. You guys are going to know these things, though, right? Here's a few more that we may not actually have names for. We should be familiar with the following, which is the substitution property. Okay, the substitution property effectively states that if A is equal to B, then A may replace B. It's a direct replacement. There's the reflexive property, which some people kind of snicker at when they see this, which just states that A is equal to A. It's necessary, though. We're going to need this, especially when we are doing proofs of triangles, okay? When we prove triangles to be congruent, we're going to need to prove 3 separate parts for 2 different triangles congruent. And sometimes the piece that we are going to say is congruent is shared by both, right? To fully make our argument, we do need to establish the reflexivity of something being equal unto itself. Next is the symmetric property, people sometimes get this confused with the previous, but it's if A is equal to B, then B is equal to A. I think sometimes students struggle with the symmetric property because they don't even see it. It's the notion of when you solve a big algebraic equation and at the end you get x is equal to 3. If you gave me the answer 3 equals x, I wouldn't mark it wrong because it effectively means the same thing, but it's not stated in the exact same way. Okay, so it's a little bit different. After that, we have the distributive property that says that the quantity A, if A times the quantity B plus C, then that's going to be equal AB plus AC. And last but not least is the transitive property, is that if A is equal to B and B is equal to C, then A is equal to C. Now notice what that is, guys. That's just what we discussed earlier in this course, earlier in this chapter, when we discussed a syllogism, right, which is a form of deductive reasoning, almost like a double replacement, right? We have 3 statements, we have 3 subjects, A, B, and C. Each are used twice. So let's go ahead and do here our first 2-column proof. But we're going to do it as an algebraic problem. So we're going to take 2x minus 5 equal to 13. You guys can do this. I know you can, right? But I'm going to show you how we would do this in the form of a 2-column proof, proving what the answer is going to be. When we do a 2-column proof, step 1, we need to make 2 columns, make a line in the middle. The left-hand column is going to be called statements. The right-hand column is going to be called reasons. 99% of the proofs that we will do in this course are going to start this way, which we're going to restate the problem that we have, which is 2x minus 5 equaling 13 in this case, and that is given. Next. Our next step algebraically would be for us to add 5 to both sides. So let's do that. Add 5 plus 5. Now think about what property that was. That was the addition property. So when we add the same thing to both sides. Okay. Step 3. We clean this thing up, right? So we're going to have 2x, and that's going to be equal to 18. And all we did here is we just simplified the problem. Now you'll see your textbook is going to stop doing that step. And what we'll do is rather than showing our work of adding 5 to both sides, they'll go from here directly to here, and they're just going to make the justification as addition. Okay. Next, we're going to take 2x equal to 18, and we're going to divide both sides by 2, so we can get the x by itself, right? We should know that step 4, what do? Well, we divide it on both sides, so that's the division property. Gentlemen, I don't need you to identify it as a property. You can just call it division. I know you know what that is. And last but not least, we've solved our problem. X is equal to 9, and again, we just simplified. So that's how we put something in the form of a 2-column proof. We show our work on the left, and we explain our work on the right. That's kind of getting back to basics with what we are doing with these 2-column proofs. Okay? So let's do another one. We're going to solve 2 times the quantity x plus 1 equal to negative 4. And we're going to justify each step. Okay. Same deal. 2 columns. Column on the left is called statements. Column on the right is called reasons. We're going to restate our problem. 2 times the quantity, x plus 1 equal to negative 4. And that is going to be our given. Now we have a couple options here, right? We could actually divide by 2, but let's go ahead and just use one of those properties that we just discussed together in class, okay?
Mr. Gonzalez, you're on mute. If you're trying to talk to us.
Okay, so go ahead and distribute 2x plus 2 equal to negative 4, and that is distributive property. Step 3. We need to take away from both sides, right? Take away that negative, take away that 2. If I subtract from both sides, so I can get that x by itself, the next step was subtraction. Okay, next, we have to show our work cleaned up. 2x is equal to negative 6. This is simplify. And I'm going to show you what your textbook would actually do. In this next step, it would say that x is equal to negative 3. Now, what did I do to both sides in order to get there, right? Technically, what did I do? I did division, okay? Now, could you take the extra step and then simplify? I will absolutely allow you to do that, but I want you to see where the book is going, you know, in terms of it's going to start to not show that work, but the work has happened, and we have to justify what had happened in between those two steps, okay? Last but not least, I'm going to show you guys the difference between addition and then one of the postulates that we've already discussed in this course that we're actually now going to be able to utilize. So we need to make the following diagram. All right. Go ahead and copy that down. Now you need to label all these. We have R, T, S, P, and Q. And we have angles 1, 2, and 3. Now you need the following arcs. We're going to put an arc around 1 and 2, and another arc around 2 and 3. What it's going to show is that I have two congruent arcs here, okay? So here's what we are given in the problem. What we're given is angle RTQ is going to be congruent, right, with angle PTS. Remember, the vertex is listed in the middle, and these two arcs are marked congruent, okay? What we are going to prove is that angle RCP is going to be congruent to angle STQ. So this is our first proof together. That's actually geometric. We just did two that were just doing algebraic problems in the form of a two-column proof. But now we're going to actually do this, which we have plenty of skill to do, right? First step, 99% of our proofs start this way. We're going to restate what was given to us. So RTQ is congruent to PTS, and that is given. Step 2. In order to create angle RTQ, what is it composed of? Well, RTQ is really angle 1 plus angle 2. Now, remember, anytime you have angle plus angle equaling a larger angle put together, that is angle addition. Moreover, PTS is equal to 2 plus 3. So this is when we're actually adding angles together to create a larger angle. Not just addition, but that is angle addition. It's not just anytime you add angles, but specifically when we get those angles equal to each other. Now, RTQ is equal to 1 plus 2, PTS is equal to 2 plus 3, and we know RTQ is equal to PTS. Therefore, angle 1 plus angle 2 is equal to angle 2 plus angle 3. Gentlemen, look at what we did there, right? What we did is almost like substitute the two values at the same time. That is the transitive property. Next step. Well, I know that angle 1 and angle 3 are the same because they both have 2 added onto it, so I could subtract 2 from both sides. Now that's not angle subtraction, that's just subtraction. Remember what subtraction is. It means that we took away the same quantity from both sides. So do I need to write minus angle 2 minus angle 2? No, but that's what happened. Now could I do that and then simplify? You can absolutely always do that. But I think some of you guys are going to start to do this problem my way because it's less writing, right? But it's fine if you actually show that simplify step right now just so you don't confuse yourself. So while you get in the habit of how we formulate our logic. So what are angle 1 and angle 3 really equal to? Well, angle 1 we also could call RTQ. And we know that that's going to be congruent to angle 3, which is also called STQ. And we did that through substitution. So just using these properties and postulates, we used one property, a postulate being the angle addition postulate. And again, properties, postulates, definitions, and theorems. There's only 4 things that can go in that right-hand column. Okay, go ahead and get started with your homework. Good luck.